Hello friends, welcome back. In the previous tutorial, we have learned what happens when we create a class and creates its instance, how constructor chaining works, and we have seen that the class inherits from object class, every class inherits from object class, and there is a base call in front of every constructor which calls the base class constructor. And we have seen that the B1 is a reference of type B which can point to an instance of type B. Then we have understood how the constructor chaining works when we create a derived class instance. When we explicitly derive a D from the B, then the D class inherits from B. Also, it inherits the members from object class also. And we have seen how constructor chaining works, and we have seen that D1 is a reference of type D which can point to a instance of type D, that is of 12 bytes. And we have learned what is reference, what is an instance, and what is instantiation. We got a clear idea about that. Then we have understood what is this keyword, what is this function call, what is base keyword, what is base function call. Now we proceed further. Now I just want you people to recall what is typecasting. Do you remember typecasting? We have learned typecasting while learning data types. Typecasting with respect to data types. Now if we want to convert one data type to another type, or store one type in another type, or one type of data in another type of memory, then we are going to perform typecasting, right? There are two types of typecasting we find, implicit and explicit typecasting. And we have seen what are the problems occur when we do typecasting. Now here you can see that on the left hand side I have an integer variable with the name inum1. On the right hand side you can see I have a floating point value, that is 40.5f. If I try to execute this line, or if we compile, we are going to get an error that loss of precision might occur. Of course, you can see that integer can hold only whole numbers. If I try to put a floating point number in it, we know that the precision part is going to lose. Integer number can store only the whole numbers, so 40 will get stored, 0.5 is going to be lost. That is the precision problem. And you can take the second example. Here you can see that I have an integer variable with the name inum2. In that, of course, we can put 800 because it's a whole number. We can put 800 inside it. Later, if I try to put that integer number into a byte memory, byte is a 8 bits. So 1 byte is equal to 8 bits. We are going to have 2 raised to the power of 8, that is 256 divided by 2, 128. Maximum I can store in this byte 128. If I try to store 800 in this byte, then we are going to get the error, that is loss of data. We know that 4 bytes of data we cannot put in a single byte. So that is the overflow, you can say. You can see that here I have a larger bucket filled with some water. And if I pour that water into a smaller bucket, we know that we are going to have loss of water. That is the size problem. So we have some issues with type conversion. You can see here in the next part, in the next row, I have a byte memory bnum2. In that 125 I am putting. Of course, we can put 125 in this byte because the maximum value that I can put is 128. So definitely I can put 125 in this byte variable bnum2. If I try to store byte into an integer which is of 4 bytes, that is possible. There is no loss of data. We know that. So here the right hand side is a smaller size bucket, left hand side is a larger size bucket. Then at that time system knows that there will be no loss of data, so implicitly it will convert the byte to an integer number and puts that value in the integer on the left hand side, right? So that is called as implicit typecast, which is a safe typecasting. There will be no problem. If there is no problem, of course system will take care of all other things for us. You can see here, if I have a left hand side a larger bucket, on the left hand side, on the right hand side I have a smaller bucket. Then the smaller bucket is filled with some water. Of course, if I pour that in the larger bucket, there will be no loss of data. So that time implicit typecasting happens, there will be no problem. When we come to explicit typecasting, then what happens we understand. Here you can see that we have a float. Again I have a float f num1 and I'm putting 250f. Here we are putting 250f, which is actually a whole number, but still it's a floating point number. Of course I can put 250f into f num1 of a floating point type. There is no problem in that. Then if I try to put the floating point value in an integer variable, in an integer memory, we are going to get the error message that system says that it is unsafe, dangerous typecasting. Explicit typecasting is actually unsafe. You can see that we have a 250 here, but left hand side also we have 4 bytes, right hand side also we have 4 bytes. I can store 250 in an integer variable, that I know that there will be no loss of data. So I can tell to the system that I want to convert it to an integer. Explicitly I am telling to the system by putting brackets and saying integer. I know system that 250 I can store in the number, you just convert it for me, no problem for me. Then what system does, it takes that 250 and puts in an integer number. There will be no problem. You can see here we have same size buckets on the left hand side and right hand side, and the water is also same thing. If I pour this water on the left hand side, there will be no problem. But let us take this bucket can store only number of liters, that is the whole number of liters the water or something it can hold. Let's take it can hold only 10 liters of water. It can hold only 5 liters of water. It can hold only 6 liters of water. It cannot hold 9.5 liters of water. If 9.5 liters of water if we pour in this bucket, then the bucket automatically throws 0.5 liter of water outside. Think like this bucket is little bit intelligent, coded something like that. Then at that time, even though you have left hand side same size of bucket, right hand side same size of bucket, if you try to pour the water, then at that time the loss of data happens, right friends? Now let's take here instead of 250, if I have 250.6f, I stored in the floating point number. Now this time, if I give that floating point value and tell to the system to store in an integer variable, then what happens here? We are explicitly telling to the system, no problem, just convert. But what happens? We are going to lose the data. We are going to lose 0.6. Only 250 will get stored. That is the reason it is unsafe. When you are explicitly typecasting, you should be very careful whether you are losing the data or not. Understanding? Whether there is a loss of precision, whether a loss of data, you need to take care. As a programmer, it is your responsibility. System won't care if you explicitly say that just do this for me. It tries its best. So that is typecasting. What are the problems that occur, and what is implicit typecasting, what is explicit typecasting, what are the things we need to take care, right, when it is unsafe. So that we have already seen. It is just a recap of typecasting. Why I am explaining this typecasting at this time? Because when we come to inheritance, also we have typecasting. Typecasting with respect to classes and inheritance, or inheritance I can say. So typecasting with respect to class or inheritance, we are going to understand here what happens when we convert one type to another type. Even you can remember that your classes are user defined types. Do you remember that? I have explained data type. There are two types of data types you get. Basic type and the derived type. In derived type you are going to get user defined types. So we know that structures, class are user defined types. Here also you are going to find typecasting, guys. Now we are going to understand what is this typecasting with respect to classes and inheritance, and we are going to, what is the responsibility of a programmer, what are the things that we need to take care, as we need to take care when we will be explicitly converting one primitive type to another primitive type. Right guys? So let's get started. Here you can see that if you have a base class, what this statement says, base class reference can point to the derived class instance. Please remember guys, instance, reference. Do you remember what is the difference between reference and instance? Please recall. Base class reference can point to the derived class instance. That is possible. That is actually known as implicit typecasting, or we say upcast. Is a safe casting. It is actually safe casting. Implicit typecasting is a safe casting, of course. Now let me explain what is this. Base class reference, of course it can point to the derived class instance. It is implicit typecasting, that means system will do this operation for us. It is actually known as upcast. Let's take an example here. Here at the bottom you can see that we have a class A, we have a class B, we have a class C, we have a class E and a class F. Here B class is inheriting from the A class, C class is inheriting from the A class, E class is inheriting from the C class, and the F class is inheriting from the C class. Here if you are converting one class instance or putting one class instance in another class, if you are going in an upward direction, that is actually known as upcast. Understanding? Converting a derived class instance, storing its reference in a base class reference is known as upcast. It will be handled implicitly. Base class reference can point to derived class guys. That is actually known as upcast. Let me explain, give you some examples so that you get a clear idea what is the meaning of that. Here we are. I take one slide. Yeah. Here you can see I can create some classes, right? I can say A1 is equal to new A, right? This is an instance. A1 is equal to new A. Then I can create B1 is equal to new B. I can create C1 is equal to new C. I can create D1 is equal to, there is no D, right? Only we have E1 is equal to new E. I can create another instance for F class also. F1 is equal to new F semicolon. So here I have created many instances and I stored their reference in the respective variables. Now you can remember here that I can store as A is the superclass, as A is the base class, it can hold the references of all these childrens. All these childrens it can hold the references. Now what's the meaning of that? If I say here A1 is equal to B1, that is no problem. If I say A1 equal to C1, no problem. A1 equal to E1, no problem. A1 equal to F1, no problem. Here you can see that I am putting the derived class instance address. These are all children of A, you can say. I can put their reference or the address in the base class or the super class. No problem guys. This will be automatically done by the system. That is implicit typecasting. If you take the example of C now, here we have a C. C is a base class for E and F. That means I can say here C1 is equal to E1. I can say C1 is equal to F1. You can see here the childrens of C1 are E1 and F1. Their reference I can store in C1. And access the members of E1 and F1 if I want. So this will be done implicitly guys. This is actually known as upcasting. From derived class to the base class we are moving. Understanding? This you should understand. Now I hope you guys have understood what is upcasting. Base class reference can point to the derived class instance. We understand step by step. Now let's understand why base class reference can point to the derived class. You can see on the right hand side here, we have a generic class with the name game object. Right friends, here we have a generic class with the name game object, and we know that every element in the game is a game object. We know that player is a game object, enemy is a game object, coin is a game object. And here again, all these members, all these game objects, you can say all these elements, player is inheriting from the game object, enemy is inheriting from the game object, coin is inheriting from the game object. If you see here, for enemy, there are two children available down. There is another enemy which is intelligent enemy, which is little bit intelligent enemy, which is inheriting from the enemy class. Whereas dumb enemy class inheriting from the enemy class. Here, these two are inheriting from the enemy. So this enemy class is actually the base class for these two classes. Now if you need to try to understand, as we know that inheritance is a relationship, right friends? Player is a game object, enemy is a game object, coin is a game object, right? Here intelligent enemy is an enemy is a game object, hence intelligent enemy is also game object friends, that you should understand. Dumb enemy is an enemy is a game object, so dumb enemy is also game object, that you should remember. Now here game object is a base class which can refer to any of these classes instances. If I create object of the player, I can refer to that by using game object. If I create an object of an intelligent enemy, I can refer that by using the game object. If I have a dumb enemy created one object, then I can refer that by using the game object. Now it makes sense also, right? Is a relationship. So we can understand that step by step why base class reference can point to the derived class, why we won't get any problem. Let's see that and then we go to the next part. Now let's go back to the scripting. Here we have a class B. You should understand here guys, class B is a base class for the derived class D. Now class B has X and Y and it has its constructor, and derived class D also has its own constructor. We have explicitly written base call so that they can call the base class constructor. That's okay, no problem. Now here we already know what happens if I say B1 equal to new B. We already know D1 equal to new D. What happens? We clearly understood in the previous tutorials. Now what I do, when we work with classes, when we later create larger projects where we will be having many number of game elements or game objects, we come across with situations where base class is going to refer to the derived class and access the derived class members, execute the derived class methods. We come across with such a situation. We see these examples practically also later, but here we need to understand the concepts very clearly, because inheritance is one of the most important part, which if you understand the flow of execution and understand how inheritance works, we can create very good code. That means we can create the project which has less redundancy. There is less redundancy there, and the code is more manageable, easily extendable. Understanding guys? So try to understand the inheritance concepts. So we are going to understand typecasting now. First thing first, what I do, I just delete this. I explain you step by step. As we know that base class reference can refer or point to the derived class instance. So what I do, I create a derived class instance D1 is equal to new D. Here I am creating a derived class instance, that we know, right? And what happens if I execute this line of code? We already know that. Let me show that over here in this page. Now we know that when I say D1 equal to new D, of course the new keyword is going to allocate a new memory block which is going to have total 12 bytes of memory, because X and Y are inheriting from the base class down here. So even its own member Z is there. So 4 plus 4 plus 4, 12 bytes of memory it allocates. So I create a memory block here. On the heap it allocates the 12 bytes of memory, guys. One for X, one for Y, and one for Z. This one is X, this one is Y, and this one is Z. And we know that in this block of memory is coming from the base class, and these members are referred by the base keyword PASE, base keyword, which is of type B. In our case, of type B. This whole instance is of type D. That also you should remember. Right, friends? This whole memory block that we find here is the D type. Whereas this block, the inner block, is of B type. That also you should remember. And the new keyword initializes these members to 0 and 0 and 0. We know that. Right? That's what the new keyword does. Then it calls the D constructor. It sends the address of this memory block. Let's take the address is #9 is the address. #9 is going to be sent to the D constructor. Then D constructor calls the base class constructor. Then the codes will get executed. We know the flow of execution of the code. I don't explain those things. Then it comes back and puts that address in the D1. Of course, on the stack we will be having the D1 memory location, that is of reference type, and it holds the #9 inside it, #9. And what system does, then its D1 starts pointing to this memory block. And you should remember that D1 is of type D in this case. D1 is of type D because it is of type D. If we can see that, if we want, we can see what type of object it is. Let me come back here. I just want to tell you people need to understand these things very clearly, guys. Now here, if I say debug.log D1, guys, you know that D1, as it is inheriting from the base class B, we also know that base class is inheriting from the object class. There are a few methods which are coming from the object class, right? Few methods like we have seen like D1 dot, if I put, D1 dot, if I put, we get equals method, which is coming from the object class, get hash code, get type, toString. These are the methods coming from the object, and these are X, Y, Z members at present D is pointing to, right? X and Y are from the base class, Z is from the derived class. I can get what is the type of this D1 by using the get type method. Now get type returns the system.type. It returns what type of instance it is. I will show you. If I say get type bracket dot toString, I can call toString on it, semicolon. Now get type is going to return the name of the class, that is D. It returns here D. Even I need not write toString. I just can write this much only, no problem. If I save and run, we get the output as D. And also we know that the D constructor is going to call its constructor, and it calls the base class constructor. We get the information in base class constructor first, then we get in D class constructor. What I do, I comment those two lines so that I do not want to execute and see those outputs. I just want to see only what is the type of D1. Let me save this, come back to Unity and show you that it is of type D. If I run the code, it's taking a little bit time. You can see that it is telling D. It has displayed D, guys. I just clear this, I come back. I can say here D1 is a reference of type double quotation plus and say equal to here. So if I save this and run, I am going to get D1 is a reference of type whatever the type is, D. It will display in front of that. If I come back and show you, you can see that D1 is a reference of type D. Now one of the important thing you need to remember here is D1 is meant to read or refer to all these memory locations. It can read total 12 bytes of memory. It can read X, it can read Y, it can read Z, it can assign the values to X, Y and Z as it is pointing to D. That you should remember. Good. Now we have created the derived type. We understood what is what. Let me comment this line. I hope you guys have understood from where you are getting the get type, how get type is helpful to find the type of the instance. Very useful. Now what I do, I create a base class variable. As we know that the base class can refer to the derived class instance, right? So I create here B1 is equal to D1. Can you see here what I am doing? I am taking the address that is D1 is holding. I am putting that in B1. Let us understand what happens when this line will get executed. If I save and come back to Unity, definitely I am not going to get any errors. Only warnings will be available because implicitly it converts. We can see that only warnings are there. We don't have any error message. It works. There is no problem. As we know that base class reference can point to derived class instance. That you should remember. Understanding? That means it can hold the address of D1 inside it. Now what happens when this line will get executed? We understand here. Let me come back. Here what happens, you should understand, friends. As left hand side is a B1 of type B, which is a reference type. So what system does, it creates one memory location on the stack and its name is going to be B1. Its name is going to be B1. As we are telling, store the derived class, this instance, derived class instance #9 address in B1. So we are storing #9 in it. Okay. Once we store the #9, we know that it starts pointing to this memory block. Here, the B1 is of type B, right? We know here, we have seen that D1 is of type D. I just comment this line and show you. Just I create B1 is equal to null I store at present. That means it is not pointing anywhere. Or I can create one new memory location itself is equal to new B. Let's take, I have created a base class instance, full instance I have created. And I can show you what is the type of B. Here, I can show you with the beginning. Let's take here, we get null reference, that's not problem. Here you can see, I say here B1. B1 is a reference of type. I can say here B1.getType. So if I save and run, it shows here B. It tells that B1 is of type B. If I save and run, come back to Unity, and if I run the code, you are going to find that if I run the code, you can see that B1 is a reference of type B. D1 is a reference of type D. Very, very useful method from the object class, friends, which is inheriting. Whereas, if I say now B1 equal to D1, okay, we are telling B1 equal to B1, it is telling a local variable name B1 is already defined in the scope, so you cannot create. I can say like this also, B1 equal to D1, or I can just comment this line. I can just say here B. I can comment this part also. I can just create the reference. I do not want to create the instance. I'm just creating the reference. So this code I just delete. You know now, right? You understood. I hope you guys have understood what is the type of B. If I say here new B, or I can keep it, no problem. Now here what happens here, if I say this time, if I copy this and hit enter, this time if I see what is the type of B1, B1 is the reference type of B1.getType. This part you should understand. Here B1 is of type B. Of course it is a variable of the base class B. We are storing the address in that of type D. If I save and run, check out what output we get. We understand this part. You should see the output as B1 is a reference type of D. What is this? It is not a reference type of B? Yes guys, you should understand this part. Remember that B1 is of type B. That is correct only. B1 is of type B. That is correct only. But system tells that the type of the B1 now is derived type D. Why? Because B1 is pointing to the derived type instance D, guys. Understanding? So B1 is now of type D, friends. Always remember that whenever you store the derived class address in the base class, even though it is of type B, it tells that as it is pointing to the derived class instance, the B1 is treated as it is of type D. Also you can see that both are having the same address, right? #9. That means B1 can point to the derived class instance. Of course, we are not getting any error message, right? B1 can point, or the base class reference can point to the derived class. And its type is now D. Why? Because it is having the address #9, same thing. But one thing you need to remember here is, as B1 is of type B, understand this, as B1 is of type B, it can only read 8 bytes of memory location. Understand this. The base class reference variable can read only base class members. It cannot read this part. Why? Because B1 is meant to read 8 bytes. Because B class has variables only X and Y, right? It has no Z. I can prove you that. I can show you that. If you come here, if you come to this place, the B has only X and Y members. It has no definition for Z, right? Now here we are not getting any error, no problem. That means system is implicitly converting, there is no problem. And also I can show you that both are having the same address in them. Both are having the address #9. Both are pointing to the same memory block. How do I show that? I can say debug.log. I can say here B1. We know that there is an object class. In the object class, we have a method called as reference equals. This is also one of the important method, which is a static method. Determines whether the specified object instances are the same instances. Whether they are pointing to the same instance, it returns. Let me show you. Reference equals, I pass here B1, comma, D1. Both instances I am passing. As it returns the Boolean value, it will return true if both are having the same address inside them. If they are different addresses, then definitely it returns false. At present, as both are having #9 in them, it is going to return us object reference equals true. Let me save this, come back to Unity and show you that. What is this? All compiler errors have to be fixed before. On what line we have error? Come on, let me clear this. B.X is never assigned to, just a warning. What I can do means I can use those X and Y. No problem. I can use here somewhere. I can write down here B1.X. You can also see here B1.X. I can access the X member. I can access the Y member. I cannot access the Z member, right? Let me comment this line and I can explain this part first, then I come to the reference equals. Here, as we know that the B1 is pointing to the derived class, it can be able to read only X and Y. It can be able to assign only X and Y. Also, I have explained this in this tutorial, in this slide, that B1 can read only 8 bytes. Why? Because B1 is of size 8 bytes. Right? You cannot assign the value to Z. Also, you should remember here that B1 can point to the derived class, but its scope is to access only base class members. That means it can access only of its type. It can point to the derived class, but it can read only this block. Understanding? Now I just show you B1.X is equal to 20 F, B1.Y equal to 20 F. You can see that using the base class variable, I am assigning the value to the derived class instance. Can you see that? Using the base class variable I am assigning. So if I save this much and come back, we should not have these warnings also, right? Only it is telling that d.z is never assigned, will always have the default value. We are not getting any error message. But if I say this time b1 dot, I don't have z in this list, there is no z, but even though if I try to say z equal to 20f semicolon, if I say explicitly, I'm just trying. If I do like this, I am going to get the error message. The error message is, it tells that base class, that is b, don't have the definition for z. Let's come back and see that. You can see that type b does not contain a definition for z. It is telling that b does not have the definition for z. There is no extension method z of type b. It is telling that you are trying to access z memory location with the base class variable b1, and we know that in the base class there is no definition for z, so this line not allowed. System itself tells you it is not possible. So referring to the derived class by using the base class is a safe method of reference. There will be no problem, friends. Automatically systems takes care of a lot of things. Understanding? Now we come to this place. I just want to prove you that base class reference variable and the derived class reference variable both are pointing now to the derived class instance. By this line I can prove that. If I save, come back, will not be having any errors, only warning is there. If I run the code, we should get true here, the last output should be true. You can see that I am getting the result as true, guys. That means both are pointing to the same instance, but you should remember that whatever the left hand side of like class name you have, only those members are accessed by the reference. Here b1 has left hand side b, so it can only read the b class members from this place. Of course, that makes sense, right friends? So that proves a lot of things from this place. We have seen that base class reference can point to the derived class instance. It is implicit typecasting. Explicitly I need not to write anything. It is an upcast because we are going from the derived class to the base class, and it is safe casting, so you need not to worry about anything. Explicit typecasting means here explicitly you need to tell to which type you are casting. So here d1 is of derived class d. I am telling that typecast it to b. Actually implicitly, even though you do not write these two brackets, if you control z, even though you do not write here bracket b bracket, system automatically writes implicitly. It will put this one based on the left hand side. It checks that okay, left hand side you have a base class b, so implicitly it will write here bracket b bracket. Explicitly if you write bracket b bracket, there will be no problem. If I save, come back, we will not be having any error message. That is actually known as explicit typecasting. Explicitly you are telling that convert the d1 to b type. In this session we have understood that base class reference b1 can point to any of the derived classes, any of its childs, safely without explicit cast. System will take care of it. And we know that even though it is telling that I am of type derived class D, as it is pointing to the derived class instance, you should remember that its scope is limited to the base class members. It can read only base class members. And we have understood how do we get the type of some instance, how do we check whether two objects, two reference variables are pointing to the same memory location. Reference equals, which is in the object class. I think for this tutorial this much is enough, friends. Watch this video again and again, understand clearly what I wanted to explain in this tutorial. Thank you guys, thank you very much. See you in the next tutorial. Keep learning, keep coding, keep sharing. In the next tutorial we understand the next part. Thank you guys, thank you very much.